in our battery-based video sizing series. This video we're going to be talking about SOC, DOD, and how they relate to the watt hours of the battery. So we'll start with SOC, stands for state of charge. State of charge is the equivalent of how full the battery is. DOD is depth of discharge. It's basically a representation of how empty the battery is. Together, when you add the SOC to the DOD, they must add up to 100%. And that is what we are talking about in units for measuring the two is percentages. So if you have a 40% SOC, that means you must have a 60% DOD. If you had a 20% SOC, then that means you must have an 80% DOD. So a 0% SOC means that there is no power at all in the battery. It has 0% charge. A 100% SOC means you have a completely full battery. So these maximum SOCs, or I guess I should say maximum DODs or minimum SOCs, are set in order to prevent the battery from being over discharged. If you significantly drain your battery on a regular basis, an example would be every night. You have a small battery bank system, the bank can barely get by for 1 day of autonomy, then those batteries are going to have a very short life expectancy, probably just a couple of years. The industry standard is a 60% SOC, a 40% SOC or a 60% DOD for your settings on your charge controller. And basically that means the batteries are always at least 40% full. They're never more than 60% discharged. The system will turn off if they get more than 60% discharged. This will give batteries, lead acid batteries, around a 5-year life expectancy. However, if you reverse those and you do manage to keep a 60% SOC and only use 40% of the battery capacity at any point, you may be able to get an 8 to a 10-year life expectancy out of your batteries. So that's one important note on the settings for the state of charge that is set by a customer. Now the downside is the lower that you discharge the batteries, the larger the battery bank must be in order to accommodate your needs. So for our question number 2, it asks, what is the watt hours of each battery? Well, we have to know how much we can get out of the battery without discharging it. So we also have to have already determined what our discharge rate that we're going to be using is. So for question number 2, my math would look like this. My volts of the battery are 6 volts, so that would be 6 times my amps or my amp hours of the battery is a C72 is 245 amp hours, so 245 amp hours. That's going to give us the watt hours that are going to be used for our battery's total capacity. So that's going to give us our watt hours that the battery has. And now I will need to take that and multiply it times the allowable depth of discharge, which my information up here at the top didn't provide that. What it provided was my state of charge of 30%. So if my state of charge is 30%, that means my allowable depth of discharge would be 70%. So I take my answer, my watt hours, and I multiply it times my percentage that I can discharge, and that would give me my usable watt hours. All right. Again, for each discharge rate, this is going to change. So if we were going to try to see how many watt hours the battery would give us over 1 day, I would end up having to use 225 in this location right here. If this was a 12-volt battery, then I would end up using the voltage right here. This comes down to my Ohm's law chart. But once I've determined the total watt hours that the battery is capable of delivering, I then have to derate it by the percentage that my depth of discharge is going to be allowed. And that will give me my usable watt hours for that specific battery. Now, I could apply this to an entire series of batteries, or I could apply this information to an entire bank of batteries. But either way, it's the same information and it's the same formula that is needed.